We started our ducting line with standard convoluted ducting. We made it for Rocketdyne in California in the 1970s. At that time, the problems with ducting, which were mostly tape wrapped and still are, were burn through, leakage through the body, and cracking due to flexure. So we looked at this, and I was told by my engineering staff that this is a really old design. It was designed in the early 60s, and it was designed for misalignment. Well, it takes a man and a boy to move these things. It's not that simple. It doesn't work that well unless you have multiple convolutes. Because we don't tape wrap, we compression mold. The burn through and the leakage through the body are non-existent issues because any air that was entrapped would lead to huge bubbles in the process of forming it. And the density is so much greater that you cannot get leakage through the body. In fact, the density for our material at 50 thousandths thick is half that of aluminum. We use 50 thousandths as our baseline for all testing, just as a point of information. The cracking we took care of in a very different way. What we've done is we redesigned convoluted ducts to deal with the very basic problems of installation and motion. This is a half of a duct. I'll show you a whole one in a few minutes. The way this works is instead of a 90-degree angle here, we've built in a rolling diaphragm. So no matter how many times you move this, you will not crack the material. And as you can see, you can compress it totally, which means even if you have a very narrow gap, you can install your duct. As far as motion goes, you can get enormous motion in any direction with very little effort as opposed to current convoluted ducts. This has been so successful that we've been able to do left-hand and right-hand parts with a single tool as long as it's not an enormous degree of motion. That in a full duct looks like this. And as you can see, you get tremendous motion, very easily done. The second, or the next, probably not the second, but the next thing that we looked at is the band clamp. Band clamps are universally hated by mechanics, and they are the reason for ducting being unusable very quickly, because as soon as you tighten a band clamp enough to seal it, you actually create a set in the part, and it will have to be thrown away. So what we did instead is we took from our metal connectors, which I will show you shortly, and we changed the configuration of the duct. We added, instead of a lip, we just made it a radial seal, which is just a dimensional change. Designed to fit over a MS33660 bead, pops right over it. Nothing we make requires a tool to install it or take it apart. And then we added two pieces that are actually life of the equipment. One is a compression ring, which simply is pushed over the lip of the seal against the bead. This is now a sealed system. Our seals energize, as I said, at around 6%. Therefore, this is enough to create the seal. The end cap keeps it from vibrating off. Our end caps are designed to only go on one direction. Again, we've worked with lots of mechanics and try to make it as foolproof as possible. Once it's in place, it snaps on, there is an audible click, and it's done. It's almost a quick disconnect. It's very easy to remove. But once this is in place, nothing can be moved. There's no hoop load on this. It's strictly a matter of retention. This allows you to narrow the envelope. The two pieces of metal are life of the equipment, and you've just extended the life of your duct about 40 times, very much as we did with seals. The same design was used for the 787. These are all the air management ducting for the 787 come from us, and this is the exact design that's used, which is the Z-volutes on each side, although we made this electrically conductive. We can do convolutes, as you can see. This is an igniter cover, and it had to extend 6 inches to 3 inches, and with an oval, I guess, base. So again, configuration is not an issue. It's just a matter of knowing what is needed. The very first part we ever made told us that we could do all of these things with an overlap. Well, not the very first part, but the first duct. Boeing had an issue in the 1970s with power plant and strut. Everything in the system was good except this fire cover, and they needed to replace that without changing out the system, but they couldn't install anything because there were large units on either side. So they challenged us and said if we could design something that could be installed without taking the system apart, they would test it and be very interested. So we designed a wraparound duct, which simply rolls up and then is clamped. They took one look and said the FAA will not buy that. It looks like it's a leak path. It's not going to work. But they tested it, and I still have the test report, which is very rare. Boeing doesn't give things away very often. This is not a fire path. It actually is a labyrinth seal. That's what led us to these kinds of configurations, because through empirical testing, we discovered that we really only need about a 1/4 inch overlap to be completely fireproof. That works in ducting as well as in gaskets. And in fact, we are currently doing for NASA a 9-foot diameter U-shaped seal that will be made to install on its own, overlap, be bonded together, and move. It's 2 disconnected cylinders, completely independent, that move in any direction. So it has to be able to move in any direction and still seal. Interesting challenges we get. Again, ducting size is not a huge issue. We can, by the way, do things in different colors. In most cases, what this is a single ply of whatever fabric we need or rubber we need to color it in whatever color we need. The silver they're both silicones in this case, but they could be anything. They're sacrificial. They will burn off or wear off eventually, but when they go in, they look nice. And on to couplings.